back everyone. Now our third question is write algorithm for Gauss-Jordan iterative method compares performance with Gauss elimination method. So this is the algorithm for Gauss-Jordan iterative method. So first step of this algorithm is read n from the user. Then in second step we will start a loop for I equals to 1 to n. Then inside this I loop we have another loop for j equals to 1 to n, and we will read matrix A of ij. Then in second step we will convert matrix into diagonal matrix by performing various row operations. So first we will start a loop for I equals to 0 to n. Then for inside I loop we have another for loop for j equals to 0 to j less than n. Then we will check condition if I is not equals to j. Then we will initialize ratio equals to a of ji divided by a of ii. And then inside j loop we will start another for loop for k variable, which is k equals to 0 to k less than n plus 1. Then we will initialize a of jk equals to a of jk minus ratio into a of ik. Then in next step we will find the unknowns and print the value of unknowns. So code for that is we will start for loop for I equals to 0 to n. Then we will print the value of uh, a of I n divided by a of ii. So this is the solution. Now we will move to our next question. So our next question is iterative method are superior to elimination method. Write four disadvantage of Gauss elimination and write three advantages of Gauss-Seidel method. So this is the answer for the question. Four disadvantages of Gauss elimination method are: first, computation is complex. Second, numerical stability. Then in third, it required pivotal condensation. And fourth one is require large memory for large matrices. Now three advantages of Gauss-Seidel method. So first one is it provide convergence. Second, memory efficient. And third one is parallel computation. So we have given a question. Consider the following sparse set of equations. We have given four equations. These are the four equations, and we have to find values of x1, x2, x3, and x4 by the help of Gauss elimination method. So this is the solution. We have converted that equations into form of augmented matrix, which is this. Now we have to convert these elements below the diagonal element as 0 by the help of these diagonal elements like this. So in original matrix, we will perform various row operations. So first row operation we will perform in R2 to make this element as 0 by the help of this diagonal element. So R2 tends to R2 minus under bracket minus 1 divided by 2 into R1. On performing this operation on this matrix, we get a new matrix which is this. Now we have converted this element as 0. Now from this diagonal element, we have to convert these elements as 0. So for R3, we have to convert it into 0, and R4 is already 0. So R3 tends to R3 minus under bracket minus 2 divided by 1 into R2. So on performing this, we get 0 in R2. Now we will move to next step. We have to convert this element as 0 by the help of this diagonal element minus 4. So operation on R4 is R4 tends to R4 minus 1 divided by minus 4 and into R3. So on solving this operation, we get new matrix which is this. We have converted all the elements 0 by the help of these diagonal elements. Now we will find values of x1, x2, x3 and x4. First we will create the equation. So first equation is 2x1 minus 2x2 equals to 1. Then second equation is x2 minus 3x3 equals to minus 1.5, and third equation is minus 4x3 minus 4x4 equals to minus 4. Then our fourth equation is minus 2x4 equals to 2. Now on solving these equations, first we will solve fourth equation. So we get value of x4 which is equals to minus 4. Sorry, minus 1. Then we will put this x4 value in equation number 3 to get the value of x3. So we get x3 equals to 0. Now we will put x3 in equation number 2 and we get value of x2 which is minus 1.5. On putting this x2 value in equation number 1, we get value of x1 which is minus 1. So this is the solution. So thank you everyone.